Hi, welcome back to the channel. In this lesson, we'll solve for the current in each arms of this DC network using source transformation and nodal analysis. What mentioning is that you can use only nodal analysis for this network. But I want to use it to further explain how to perform source transformation and nodal analysis. That said, let's get into class. Now, like I explained in the introduction, I'll be using source transformation. So what we'll be transforming first, we'll be transforming this voltage source into a current source. And to transform this voltage source to a current source, like I explained in our lesson, we explained source transformation, you have to pick the voltage and the current and use our formula V is equals to IR, Ohm's law. So that my V here is the 20 volts is equals to I, which is the current we are actually looking for, times R 4. So that obviously my I will be the same thing as 20 over 4, which is equals to 5 amps. So that which is equals to 5 amps. So that the circuit now begins to look like this. Here is my 5 amps and here is a 4 ohms. In case you missed our introductory lesson on source transformation, kindly do look at the description below. We have placed a link to that lesson. Now, the next thing is for me to actually identify my nodes. Now, if you look at this circuit, there are plainly two nodes in this circuit. One common mistake students make is to think of it as a three-node circuit, but rather I have two distinct nodes. Here is my first node, and here is the second node. Now, this is not an external node. I'll associate these two as one node so that I can easily redraw my circuit. Here I have simply redrawn my circuit so that I have my first node. Here is node 1. Let's start this node 1, and here is node 2. So from here, this is my current I flows to node 1. I'll have this is I1, here is I2, here is I3, here is I4. We can now begin to solve for this circuit so that at node 1, I can say that the current entering node 1, is equals to the sum of the current leaving node 1, I1 plus I2 plus I3. Let's define each of the currents. I itself will come from 5 amps. If you look at I here, I is the same thing as 5 amps. So that my I is equals to 5 amps. My I1 will come from, I have this, let's tag this voltage at 1, let's tag it VA. Will come from VA over 4. That's equals to I1. And for I2, I2 also will come from VA over 4. And for I3 will come from this loop. I have my loop from the reference node to VA and to VB. The voltage will target VB to VB. So that will be VA minus 5I3 minus VB is equals to 0. So that VA minus VB over I3 or over 5 is equals to I3. That way, we have defined all of the current at node 1. So that at node 1, we're saying that 5 in place of I is equals to I1, that's VA over 4, plus VB, or VA, sorry, still VA over 4 for I2. For I2, VA over 4 plus VA minus VB over 5. Now I have 4, I have 5 as denominators. I prefer to multiply through by 20, so that this is 100 is equals to 5 VA plus 5 VA plus 4 VA minus 4 VB. I've multiplied through by 20. Now, so that 100 will be the same thing as 5 plus 5 plus 4. That's 14 VA minus 4 VB. Now let's reduce this. I have all in the, now let's reduce this. They are all even numbers. I can divide through by 2. So that this is 50 is equals to 7 VA minus 2VB. Let's open another slide. At node 2, obviously I should have, let me just copy out the equation here. At node 2, we'll have I3 flowing to node 2, as I3 equals I4 flowing out of node 2 plus the 1 amps current flowing out of node 2. So that at node 2, I3 is equals to I4 plus 1. Let's remember that I3 has been defined from node 1, so we can easily pick that. My I3 is the same thing as VA. That's what we have here. Here is I3 as VA minus VB over 5. I3 is equals to VA minus VB over 5. Then I4 is the same thing as VB over 5. Here is I4, here is I4, and it's just between VB and the reference node. So that's VB over 5. That's VB over 5. So let's substitute. So that in place of I3, I have VA minus VB over 5 equals to VB over 5 plus 1. So I can multiply through by 5. So that VA minus VB is equals to VB plus 5. Now that means, let's collect like terms. So that is VA minus 2VB is equals to 5. Here's my equation 2. Let's go back to equation 1. They are looking quite similar, so we can draw some conclusions from there. Okay, this is my first equation I derived. Let's start that equation 1. So let's bring them together. Here's 50 equals 7VA minus 2VB. That's 50 equals 7VA minus 2VB. And for equation 2, I have VA minus 2VB is equals to 5. Let's multiply equation 2 by minus to subtract it from, this becomes minus 5 is equals to minus VA plus 2VB. Then we can add them together. Here's minus 2 cancels this. I'll be left with 45 is equals to 6VA. Obviously, this implies that my VA is equals to 45 over 6. That's equals to 3 here is 2, 3 here is 15. That's equals to 15 over 2. It's the same thing as 7.5 volts. Let's solve for VB. We have that VA minus 2VB is equals to 5. Now this simply implies that my VA minus 5 is equals to 2VB. We can now say that VA minus 5 over 2 is equals to VB. Now that's the same thing as VA. My VA is 7.5 minus 5 over 2. That's equals to 2.5 over 2. I think that's the same thing as 1.25 volts. Now with this, we can begin to solve for each of the currents. Let me just clear this side to solve for each. We've gotten that our VA is equals to 7.5 and my VB is equals to 1.25. Let's solve for each of the current. We already identified I to be equals to 5 amps. We identified I3, remember I3 to be equals to, I3 is equals to VA minus VB over 5. I3 is equals to VA minus VB over 5. That's equals to 7.5 minus 1.25 over 5. That's the same thing as 6.25 over 5. Now we can do the same thing for I2 and for I3. I'll be glad to do that and share your results with us in the comment section. Thank you for staying with us and see you in our next class.